Okay. This is the check your understanding number 2 that hopefully you finished in class, or checkpoint number 2, whatever you want to call it. Excuse me. So it's the same problem we were talking about before with Facebook and all that. So state a null and alternative hypothesis for a significance test to help answer the question. So our H null is always going to be, we're going to write these in words for chi-squared. It's just a lot easier. In the book they have how to write it in symbols, but it's better this way. So our H null is just that there's no difference in the distributions. Of Facebook use, we could say. Among students at the main campus. And students at the Commonwealth campuses. HA is just that there is a difference. Blah, blah, blah. Same thing as before. Get the idea, right? Calculate the expected counts, show your work. So if you wanted to do this in the calculator, you could, but since it says show your work, I'm going to make sure we see, okay, so I'm going to need the totals, because what I was telling you earlier, that extra thing that I had you add on expected count on the front of the notes, was row total times column total divided by table total. So the table total or the total total, okay? So I need to know, I'm just going to do these in the calculator because I'm lazy. 55 plus 76. Hopefully y'all understand why I'm doing this. The total Facebook users are down here, but we don't have the totals on this side, or the whole table total, so that's what I'm figuring out now. That's the table total, okay? So for each one, we can find the different expected counts. I'm not gonna bother labeling them, I'm just gonna go in order, where I go like this one, then 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 this one, okay? So there are 6 of them, so it's not crazy to do this by hand like it would have been on that first example we did, if y'all heard me talking to Amber about that in class. This one is not that crazy to do by hand. So row total, if I'm looking for this spot, right? So several times a month or less on the main campus, the expected value for that spot would be, if I did 131, because that's the row total, right? 910 times 910 divided by the table total, which is 1537. Okay. Figure out what that equals. So I'm just going to write these all out and then put them in the calculator. So after that, we would have I said I was going to go this way, so we'll do that. So 131 times 627 over 1537. So this is the, yeah, anyways. This would be for this spot. Okay. So then the next one, if I want to do this spot, the row total is 372 times column total, which is 910, divided by 1537. Then I'll do for this one, row total is 372 times 627, which is the column total, over the table total, and then the last two. So at least once a day main campus, I would say 640 times, oh wait, sorry, not 640. Whoa, got ahead of myself there. Row total, oh no, it's fine. Okay. 1034, which is the row total, times 910, the column total, over 37. Same thing it's been every time. And then the last one, 1034 times 627 over 1537. Okay, so we can figure all these out. I already have all the answers here, so I'm just going to write them down, but obviously this is something you can very easily put in your calculator. This one is 77.56. Okay, calculate the chi-squared statistic. Show your work. Okay, I am gonna start showing my work, but I'm not gonna do the whole thing. I'm gonna do it in the calculator because it's just easier. So if we were showing our work for the whole thing, remember that the chi-squared is the sum of all of the, if you take the individual, the observed minus expected squared over expected, and then you add them all together. So the first one, our observed, was 55 minus 77.56, because that was the observed for that one. It's that one. Squared over 77.56 plus ... and then I'll just do the last one. So the first one's that, and then the last one is this one. So 394 minus 421.81 squared over 0.81. Okay. When we do all of those, it turns out that the chi-squared statistic is 19.49. If we were to add together, remember this ... is doing what I did for these two, which were these two in the original table, for the other four in the middle, right? But I'm not going to do that right now because that takes too much time. So if I want to use chi-squared CDF on the calculator, remember you can do that. Oh, I have a lot of stuff in here. Dot B. Oh, this is not Scratchpad, that's why. Okay. Either way. So you can go into its menu, statistics, distributions, and then we're going to do 8, chi-squared CDF. Okay. So in the lower bound, I'm going to put my chi-squared value, which was 19.49. Because remember what the chi-squared distribution looks like. It's something like that, right? And so this is your mode, your degrees of freedom, which should be 2, but it doesn't matter. 19.49 is going to be somewhere over here. Anyway, so that's why you want to set your chi-squared as the lower bound, and then the upper bound is something big, because for chi-squared, we're looking in the tail on the right always. So the lower bound should be your chi-squared, 19.49. Your upper bound, just a really, really big number, doesn't matter. Degrees of freedom. Okay, so for degrees of freedom, we need rows minus 1. So we have 3 rows minus 1 times columns minus 1. This is just 2, this is just 1, so our degrees of freedom is 2. And that gave us a p-value of 0. Let me see, there's 4 zeros there. Is that on the screen? Yeah, 4 zeros there. Small p-value. Okay, interpret the p-value from the calculator in context. So give me 1 second. I'm going to grab our sentence stems because I want to look at that. Okay, psych. I don't have I must have given away the sentence stem that was behind my desk. But what the sentence stem did say was, assuming and then H null in context is true, the p-value of whatever it is, so you would say the probability, or there is this probability of getting a distribution or a difference in the distributions, for the context here, of this much or more in whatever direction by chance alone. So that's what the p-value is. It's a probability given that H null is true, right? So if we say that H null is true, that's the probability that we would get a difference in the distributions by this much. So it's a really small probability that it happens by chance, which is why when the p is small, we go ahead and reject H null, because we think if it's that unlikely to happen by chance alone, then probably it wasn't by chance alone and H null is wrong. Okay? So interpreting in context. So assuming H null is true, so there is no difference in the distribution of Facebook users. Dang it, difference, not difference in the distribution. Sucks. Blah blah blah. In this specific scenario, you might want to be a little bit more specific on a test or something, but I didn't leave you a lot of notes or a lot of space, and this is really just in class practice. So you might want to give a little bit more detail as far as context goes, but I think that this might be enough, really. Distributions of Facebook users. There is a 0.000059 probability probability of observing samples that show a difference of getting a result, whatever, that show a difference Hopefully that makes enough sense. In the book, if you want to look, there is the answer to this is in the back of your textbook, and they wrote a lot more than I did. But I think that makes enough sense. And if it doesn't, then let me know on Thursday. What conclusion would you draw? Well, I spoiled that a second ago because I already said we were going to reject. So, since our p-value of 0.00059 Okay, so we reject H null. There is convincing evidence for HA in context. And I actually am going to write out, I know I didn't write the whole HA up there, but I will here. I'll say use. I'm just using the wording that I used in H null since that's what the ... was supposed to, or the ellipse was supposed to, ellipsis, whatever. Okay, hopefully you can read that. It's really messy at the end, but you get the idea. I'm just restating the HA in context, and so I filled in with the wording that I used on H null since I didn't write all of HA. So that is your second checkpoint for 11.2. Thank you.